Today I'm going to start with this blueprint. Okay, so this is our programming session. So now I'm going to start with visualization of the structure of a script or a program. Okay, many people here. Okay, first of all, I just before getting started, um, you all have some kind of troubles with programming. Sometimes people may have not actually done any programming in their lifetime, but may have worked in an IT industry for 10, 15 years, or may have done something, but not at to, but not frequently. So it's a kind of an, sometimes when we say programming sessions, people always have a thing like fear. Okay, will I be able to become a programmer? Will I be able to write code? Will I be able to become a good scripter? So that's always something that people keep on asking. Okay, so that's something. So today's session, I think you can. I mean, today and tomorrow, I think by the end of next tomorrow, you will be able to uproot that fear. That is not a very tough thing to accomplish, my opinion. Okay, so that's where we just wanted to start with this. Okay, so first is today we don't have a big blueprint, okay, because we have a big hands-on to do, okay, coding exercise. Okay, so I'm going to take a task. Okay, usually we take this task and we'll show people how to build things slowly one by one. Okay, we are going to do in Ruby, we are going to do it in Python, we're going to do in Bash shell scripting also. Okay, what we do, I will explain when we do it. Okay, so first we're going to discuss about this visualization of how you can structure a script or how you can structure a program, okay, in a block based approach. Okay, so now I just open a small drawing for that. Okay, so what I'm going to do is first I'm going to start with the three important one of it. So we're going to now see three important languages. Okay, the first thing is I'm going to talk about we're going to talk about this Ruby programming language, the Ruby. Okay, and then we're going to talk about another language. I think we should not say it is the a language, but we should say it's something called as shell. Okay, particularly the Bash shell. Okay, precisely. And then if you see here, the other thing that is Python. Okay, so three things we are actually going to do today. Okay, so three languages we are going to parallelly do something with. So this is the way how we're going to get started. Now you see here, I'm going to first explain the where these languages are being used. Okay, generally we say these are all programming languages, and how frequently it's being used, or how what is the way how that is being used and all that. So what I would like to say here is these languages have certain dominance in certain areas. Okay, so we need to have this first view about when you learn anything, okay, a programming language or anything. It's always important that you first um, have a view about how that is being used. Okay, so first starting with the shell. Okay, when you start with shell, you see here, shell is basically a programming language, which it's not a language, it's a place where you input all the commands and all, but you can actually script a shell. Okay, you can script a shell. How do you script a shell? Means there is something called as bash shell scripting concept is there. So and then you can barn shell scripting is there. There are different options out there. So where is this shell is being used? Okay, so I'm going to say what's the application of it. Okay, so application in the sense, I would like to say application. Okay, the application of how this is being used. It is something which is used mostly in server automation. Okay, in the server automation, if you see here, if you can find it this place, so you can do see this shell is generally something which is very predominantly used in server automation. Okay, server automation means you need to know the background. You listen that we now you have the modern day tools here, like you have the Chef Ansible, or we have SloopStash. So there are so many open source technology, many leading technologies there in order to automate things. But if you take it into long back, okay, I mean, I'm saying that it was a decade back or something like that. You don't seriously have a very good automation tools. Okay, particularly when you want to automate a server, when you want to automate something, there is no great automation things available for it. Okay, so basically, I would say this is something before 10 years or before a decade. Okay, before 10 years or before a decade, you have to rely on shell scripting only to do server automation. There is no other way. Okay, before this time, that is the decade time, okay, before decade or maybe 13 years back or something like that, there is no option except for to do server automation. You just need to rely upon shell scripting as a practical application of shell scripting. Many times we learn shell scripting, but the practical application of shell scripting is to do more server automation. That's the practical purpose. So that's the story before a decade, but now it has changed. We have lots of sophisticated tools that helps you to accomplish that. And then if you see on this side, if you see here, the side called Ruby, okay, this is the shell scripting side. If you go to the side called Ruby, in the side of Ruby, what you can see here is this is basically a kind of a programming language which is very popular in web-based application development as well as in modern day open source tools. Okay, so I will tell where this particular tool is being used, and you know that I mean you have to know that this is basically used in different tools. Okay, used in different tools in the sense I just try to click that. So we have tools like the Vagrant. You know, we have tools like the Vagrant. We have tools like Chef. Okay, these are the tools which actually use this Ruby programming language a lot. Okay, so Vagrant, okay, what is one important thing, and Chef is another important thing which actually uses this one. Okay, so Vagrant. So Vagrant, and then you have Chef. Okay? Chef is another tool which actually relies on Ruby programming language. So these are the two tools which you see here. Ruby is being dominant there. Okay, and if you see Chef, Vagrant, these kinds of tools, they were all the tools that were there before 13 years back. Still, these tools are less than more than 10 years old tools. Okay, so that's where you can see Ruby is a very important player. And most of the time, you see Ruby is also used in web application development. Okay, basically, if I wanted to share one more aspect of Ruby, I just wanted to say that this is something which is used in web app development. Okay, so developing software products. Okay, so that's where web-based software or browser software. So it's for web applications. You can actually use Ruby. Okay, it's a very famous thing that is called as Rails. Okay, it's a very famous framework in Ruby beyond Rails. Okay, so it's a very famous framework. And then this is the story of Ruby. Okay, and if you go to Python, Python is also something having similar to this. Okay, so Python is something. If you see the tools, okay, what kind of tools we can put in the Python's belt is we have tools like Ansible. Okay, Ansible in the sense, you know, Ansible is a very important automation engine. So Ansible plays a key role in the DevOps world. Okay, it's a very important tool. Okay, and then if you see here, Python, Ansible is written completely on Python. It's a Python-based application. Okay, and then you have the, you know, we have this other aspect of Python. So Python is basically dominant in different areas. Okay, you know, Python is basically dominant in DevOps area. Python is dominant in big data areas. Python is dominant in machine learning areas and application development. So many areas Python is being used. So I would like to say that Python is generally used in big data world. Okay, so big data, and Python is used in AI ML. So many libraries. Python is very rich in big data ML libraries, and Python is good in DevOps domain. So we've been in DevOps, so you can see Ansible kind of tools completely rely on Python. It's a Python-based application, and then you have web apps development. So all these areas you can see Python plays a very important role. Yeah, Python plays a very important role in big data world, in DevOps world, in web application development. So everything you can find that Python plays a very important role. Okay, like Ruby is mostly into this web application development, but big data or machine learning and all, Ruby won't be there. But Python is a very predominant language which is being used in so many other places than just DevOps engineering or just basic application development. Okay, so that is why these three programming languages. Okay, as a DevOps engineer, if you are willing to pioneer in your DevOps journey, if you can just learn these three programming languages, I believe you will be able to, I think you will be able to master so many things. That is our view of, that's our view. Okay, so this is more than enough. Okay, these three things are more than enough for you, that if you want to survive for another decade, because if you know learn Python, you have scopes in big data, machine learning, and not just in DevOps and web application development. If you learn Ruby, you can, you have things in, I think I have to select this also. Maybe Ruby is also used in this DevOps world a lot. That I don't know. How do I select it? Web application development, DevOps, and web app development. Okay, so we have lots of varieties. Okay, so every single tool and software has its own technology, has its own cutting edge things in certain domains which we have to understand. Okay, so this is what is the summary of the three dominant programming paradigms in the DevOps world, big data, or machine learning, or web application development, or whatever it is. Okay, I just showed you how these things are applied practically in the industry, and where these tools, I mean, what kind of tools actually uses that, and what are all the places, use cases or domains in which these languages are more comfortable. Okay, this is the first step, okay, in visualizing the block. Okay, now what we are going to do is we are going to see how these things are going to play together in solving the use case. Okay, how to use script. Very importantly, sometimes people think that if I learn Ruby, I need to learn Python or all these things. So how difficult it is all about, so and all that. It is not a very difficult thing. Programming, the very important thing to learn in programming is everything is logic. Whether you write in Ruby or Shell or Python, okay, I just write it here. Whether you write in Shell, whether you write in Bash Shell, okay, or Python or Ruby, the logic is the same. Okay, the logic is always the same. That we should not forget this matter. Okay, this is an important thing. That is a very important thing. For now, I don't know how to quote that important, that round and X and all that. So I am still yet to practice all that. So you see, this is a very important thing. Whatever you write in Ruby, whatever you write in Python, I mean, in context of scripting is same. The logic is same. The logic doesn't change. It's a very important thing. Okay, so you don't need to worry really whether you write it in Python, the Ruby, or shell programming or anything. All places logic stands same. Okay, so that you don't need to worry. Will I be able to learn three languages? That is not the matter at all. Okay, first we need to come to that mindset. Okay, I'm specifically thinking about people who haven't done any programming. Okay, now, so what we are actually going to do, how we are going to construct a program or code. Okay, we need to know that whatever I'm trying to tell here, it's a very standardized process. So what I'm trying to say is, as I told, the logic is same irrespective of the matter that you have different programming languages. Likewise, the process is also same. Okay, so I wanted to put that point. Okay, what I wanted to say is, whatever language you are, okay, you're going to write the process. I mean, process means it's not the system process I'm talking about. The process of writing the script, okay, remains constant. Process of writing the script remains constant. What do I say? Irrespective of the I think I need to of the fact that you are in Ruby, Python, or Bash. Okay, so these two things we have to keep in mind. So this is one thing, and that is another thing. Oh, I think I wrongly copied. Okay, so these 2 points we have to definitely remember, guys. Okay, so whatever languages that you use, whatever you do, or this and that, the logic remains the same, and then what remains the same? The process remains the same. Okay, process remains constant. Okay. Okay, so these 2 points we have to remember, guys. The very important thing is the logic remains the same, and it's not any magic or something. So it's basically a simple logic, and then we have the what we have the script process of writing the script that remains fairly constant. Okay, so you don't need to really worry about these two things. It's all the same process. Okay. So these 2 points are very important key points that we have to always remember. So this is the way how we actually look into this. Okay. Now I wanted to go into the blocks, building blocks of this standard process. Okay. The building blocks of the standard process in the sense you see, I just want to put a very big box. Okay. Okay, so this is the way how you are going to visualize how we can use all this programming language to construct a single business logic with building blocks. Okay, every time when you see here this script, okay, let's say this is the script file. Okay, what is this now? By the way, I can simply say script. Okay, script file or script. Okay, this is what we call as something called a shebang. Okay, the first step in your block. Okay, the first step in your block is what we call a shebang. Whatever script that generally you write is generally going to start with in Linux Unix. Okay, at least in Linux Unix, it's going to be like starting with something called as a shebang. Okay, so what is the shebang now? Okay, let me write it here. So, shebang. Okay, SHEBANG. Okay, shebang. The shebang is something which I mean naturally what it conveys here is what it references the interpreter or the binary executable or the shell that is going to execute the script. Okay, so what does shebang means? Very simply, it references an interpreter. Okay, if you want me, I will try to show that very clearly and consistently. What I would like to show here is, shebang is basically like it's going to how do I say that? Reference, referencing interpreter. Okay, referencing the interpreter. So I think that should be medium sized. Referencing the interpreter. Okay. So when it references the interpreter means if you are going to write a script, let's say if it is a Ruby script, okay. So the shebang is going to be like, so it's the first step, okay. So what when I say shebang means what I'm trying to picturize here is shebang is the first step, okay. That's I just try to put that here, okay. Shebang is the first step in the code, okay. How do I maybe if I type 1 and then put a 0 over that. Okay, we can then copy paste on that. Then it looks very neat. So, sorry. So this is the first time I'm doing, so you need to adjust with me. Okay, so I need to get fruitful with before I get fruitful with that. Okay, so that is the first step. Okay, in scripting. So when I say building blocks in a script, shebang stands the first step. So there are different interpreters. Okay, interpreters in the sense, if you want to have the Ruby interpreter, the text is going to be like you have this hash exclamatory, then you have the user bin Ruby. What is this? Okay, suppose if it is going to be let's say if it is going to be the this thing Python, you may have this thing like hash like user bin Python. So this is what we call a shebang. Suppose if it is a shell script, how that is going to look is it is going to have like hash bin slash trash. Okay. Suppose if you are going to write it in let's say some other language, what are all of that? If you want to write it in a Perl script, okay, so it will be like user bin Perl. So whatever you programming languages you write, okay, so that interpreter has to be the first line, which is what we call as the shebang. Okay, that's the first line, which is what we call as the shebang. Okay, this is the first step what we actually generally see in any program, any script which you wanted to write. You have to start with this. That's why I said the process in which we actually write the script is going to be very, very, very standard. Okay, so whatever given use case that you try, I would say that because we've been doing this for years now, and we say that all these things are very, very consistent, constant. Okay, this is the first thing that we have to understand. And then, if you see the second step about this, this what the script, the block in the script is, the second step is like you have the topic. It's called the description. Okay, so sometimes people call it as documentation, or I would like to say description. A description about the script. Okay, and this is the number 2 thing that you have to try. Okay, number 2. That is very good. Looks good. So description. Description means what is this script is really all about. Now, so far I didn't say what kind of script we are actually going to write. Okay, we can go with the telemetry script then. I will tell what is telemetry, by the way. Okay, so this place, what we see here is what we generally call as the description about the script. Okay, what script you are going to write. This script, this place is going to give you some kind of understanding on, provides a better way for others to understand. Okay, to understand the script and its usage. So this is the purpose. Okay, that why the script has to be written. So what the script actually does. So this provides that understanding. So in our case, okay, so every time when you write a description about a script, generally we have to have it like I would like to say black. We start with the comment symbol, or comment means hash. Okay, every time wherever you write a description in a given what in a script, okay, inside the script or in the top of that, wherever it is, we need to always have to use something like hash to start it with. Okay, so it always starts with the hash. Okay, it's not a shebang. So basically I'm going to say get system metrics or process or calculate system metrics data, or in simple terms, calculate telemetry data. Telemetry means system load, system metrics, whatever it is. Okay, so something related to system. Okay, so telemetry means there are lots of meanings for the log data, metrics data, and this data, that data, and all that. So all those are telemetry data. Telemetry data. So the telemetry data is what actually we are going to process. Okay, calculate telemetry data and calculate and send to an observability and send to an observability platform. Okay, we don't have an observability platform here, but still what I would like to say is the purpose of the script calculating the telemetry data and sending it to an observability platform is the purpose of the script. That's all. Okay, and then if you see here, this is second step. It's what we call as description. It always starts with something like hash. This is how it looks. Okay. The third step in the code in the script is, we have to have this third step, which is importing. Okay, we may need to load lots of libraries. Okay, so loading the libraries. Sorry, I think loading the libraries is very important because your system may need lots of libraries and things to be used, right? So what I would like to say is load or import. I think I have to move this here. Load or import libraries or and modules. Okay, so this is the third step fairly in any given script. Okay, loading or importing the libraries and the modules are the third important step. Okay, so that is that. 3. Okay, this is the third step. So what kind of things that you basically load here? So when I say loading libraries or modules, means what that it literally means. With an example, I would like to say that you see, we have let's say, just move this in. So in Python, for example, in Python, if you want me to say that there is something called as importing modules. Okay, in text first, I will explain what this is all about. So this is to really load and import custom modules and libraries that is required by the functions and by the script, required by the script. Okay, so required by the script. So whenever you write a script, it's not just you just like that write it. We need to have lots of. It's not about just one thing. You have to have lots of libraries, function, because that actually produces the custom functionality. You can't sit and write all the code. Okay, there are lots of ready-made code is there. You should be able to use that as a library, and that is what actually this third step is going to do in any given programming language. Suppose if you want me to give some examples in Python specifically. Okay, in Python we have something called as import module name. So import module name in the sense, let's say import time module. So import OS module, import system module. So these are all the imports that we generally do. I think similarly in Ruby also, I think there is something called as includes. Okay, so I rarely forgot the syntax. Okay, but for now I just start with Python itself. So this is what we are literally talking about. The keyword itself looks like this. So importing. So when you wanted to write a code, you can import, sorry, ready-made modules. We can just import all these things like that. Okay, and then just call the functions inside that can be used actually. Okay, so that is what this importing is all about. Every time you write a script, the first is the shebang, the second is the description, and third is the importing of the library. So that should be the third step. And then we have the fourth step. Okay, naturally, always the essential step, but that is very important in scripting, which is what we call as access control management or access control levels. Okay, so I would say that this is something like implement access control for the script. Okay, so this is fairly always the third block. Okay, so implement access control for the script. I think I'll move these things to the left side so it looks better. So left side. So description. So implement access control. So that is the fourth step we have to have. Fourth step. So the fourth step is generally the access control means who can actually execute the script, for whom it should be denied. That logic must be there. So access control mechanism implementation must be there. Okay. So that is what is the fourth step is going to be. The fourth step means what generally, shell scripters generally what they actually do is, I'll tell one simple thing which we've been doing for a very long period of time. Okay. If you see here, I just try to write it in this way. Most of the time when we write scripts, okay, for automation purposes, I mean, ad hoc scripts, we don't allow the normal users to execute it. We only allow the root users to execute it. Okay, so that is the important thing. So normal users are not allowed to execute, but only the root users were allowed to execute. So here, I just want to say like a control who can execute. Script means executable, right? So that's nothing to read and write and all mostly. So who can execute the script and who cannot or who should not execute the script. So that is what we generally call as the access control mechanisms. Okay, so it's what we call as implementing access control. Access control means most of the time you may have this scenario that I'll just try to tell that. Root user allowed to execute, mostly administrative tasks. So you have to be sudo or else a sudo or a root user is allowed, but normal users you deny. So I just write it as a condition. So now we can say it like this. Okay. So how do I write it? Only root user and sudoers are allowed. Okay, so such thing, but you don't want to allow the the normal guys. Okay, normal users are not allowed. Normal system users are not allowed. So this is the logic. Okay, most of the time when you see the scripters who've been doing all these things for years, they have this fairly simple, plain logic which they actually try to implement, and that's what we see here. Okay, only the root users allowed to execute. Sudoers are allowed to execute. Normal system users are denied. It's a simple piece of access control mechanism. Nothing great in that. Just an if-else logic. That's all true or false. And this is what is going to be in the third level. Now, remember, as I've been talking this, I'm talking in the not in the context of Ruby program or a Python program or a shell program. I'm actually talking talking about a very standardized process. Okay, so I'm not into Ruby, shell, or Python. This is a standardized structuring of a scripter. Okay, if you've been doing script for more than a decade and all that and doing automation, at this time we have to come to that level that we see things through structures and layout. We should not see syntaxes. Okay, syntactical understanding will evaporate. Maybe if you ask me if else syntax in Ruby now, I don't know. Okay, so I have to see that and I have to do it. That's sometimes it will be there, sometimes we forget. It's not possible. Okay, but the structuring and the layout creation for a script or a program has to be very, very, very consistent. Standard process. You cannot change on this. You may have customized, but the process we have to really follow. Okay. And then the next step, what we actually generally see here in this place is what we call as the variables, the global ones. You know, every time when you have the script, you have this constant variables being stored on the top. So this is something related to that. Okay, so I just want to copy the same thing and I just put it here. So this place is what to say? What is that? Include global variables. Okay, so setting global variables. So that's the next step. Okay, so fourth, and this is the fifth one. Okay, fifth step. So what is that global variables? Okay, so global variables are generally the variables are not something which is a function specific or not something which is going to be used inside a specific thing. So it's throughoutly accessible. It's a global one. Okay, so global one means it is throughoutly accessible, and that's what we call as. That's why it is called as global variable. Sometimes people call it as constants. Okay, you know, I will give all these things with examples. Now I'm first trying to lay the foundation of good programming. Okay, that foundation has to be right. Then I think we can very easily write to programs because it's nothing but syntaxes and stuff. That's all. Okay, so now just what do I say? So define. I think the best word is define global variables. Okay, so define. It's called define. Okay, so define custom global variables that that can be used um, throughout the script. Okay, define custom global variables that can be used throughout the script. Okay, which means accessed inside the functions, accessed inside whatever place you want, you can access that. Okay, so this is all very important things. So the building blocks of a script. Okay, so if you, I mean, when I write it, I will give an example. Certain things we can't write an example here. Okay, now if you see, we are now in the halfway mark. Okay, this is the way how our thing looks now. So where we started now, we started with the three different programming things. Okay, so we didn't see shell in the context of a command line input provided. So we are going to script the shell. So where the shell is being used, it's the server automation place is the place it's being used. And I spoke about Python, and then the background, and then we have the chef. Then we have this plot, shebang description, loading this libraries, implementing access controls, and then the global variables. Up to this, it's a standard structure. It's a standard structure. Okay, we're going to see how we can get into constructing the logics. Okay, so far, if you see here, we are not actually constructing any logics here. Okay, it's so far it's all about, we have the with the standard structure. Okay, nothing specific to the functionality or the logic or what the script is going to. That actually we didn't do anything here. Okay, so that part is something like we're going to now explore. So that's where we see something called as functions. I'm just dragging it down. Functions. I need more space. Okay, functions. That's one of the most irritating words that people generally, people who've been in the industry for more than 10 years and haven't done any programming, when we say functions, call by reference, call by value, and all that, okay, they say, okay, it's a kind of an irritating word for them. Okay, but it's actually not an irritating word, provided if we learn that in the right way. Okay, so I'll tell what it is. So far, what you have seen here in the script structure is all just the layout, okay, or standard things. Now we are going to see how to write our logic. Okay, what does the script do? That is the logic. We're going to now write the logic. Most of the time, when people try to write the script, okay, what will happen is that we try to write something like this. Okay, so we write. So write. Okay, sometimes people write shell scripting. I've seen. Okay, so for many years, when we tell people to write shell scripting, they write code in a very sequential way. Okay, you can use the shell script, run it, and that doesn't have a very greater flexibility. Okay, it's what we call a sequential coding. Okay, and this is not the way how we code. Okay, so the first thing as a good programmer, okay, that is we need to break down the functionalities. Okay, now remember the word I'm using. You have to break down the functionalities. Okay, so what is the script is all about? I said the script is all about calculating the telemetry data to send it to an observability platform. Okay, so we're not having observability platform, but we're going to calculate what is the telemetry data. Now, what is the telemetry data? That is the use case we have taken. So what is it? What is that telemetry data? Very simple. That says your functionality of the script. I would like to say the telemetry data is about, it is something which is going to, let's say, let me open my terminal and I will show you. So and then you will understand that. What is the telemetry data means? I hit this W command, you see here, there is something called as 1 minute load, 5 minute load, 15-minute load. It's a system performance telemetry data. Okay. So if I run these commands we ran in Linux sessions, it's not anything alien for you, all that. Okay. When I run this df-th command, this system size used available is there. That's what we have in the SDA2 device. So that's a telemetry data. Okay. In modern day DevOps engineering world, okay. So I don't know, but there is a topic called Elasticsearch LogStash Kibana. Okay, that is one of the key dimensions in DevOps. Okay, which is what we call as the observability in DevOps. Okay, maybe you may have what the observability engineering. Uh, uh, I mean, I think it's like SRE. If you have listened to some job descriptions these days, they say DevOps SRE or observability in DevOps or DevOps observability. You may see these words combined or SRE observability or observability DevOps. So you may find something in the job description. Okay, so I'm not going to talk elaborately on what it is, but I'm just saying, throwing lights on that. Okay, this is a very another dimension or a segment in the DevOps, like you see CI/CD pipeline, you have containerization, orchestration of containers, automation, deployments, workload man. So everything is segments. Okay, like that, you have observability as an important segment in DevOps. So very important thing. Okay, but due to time factor, we weren't able to convey this ELK things and all that. But last batch also we said, okay, I think we need to, if people are willing, we can share the book and people can try it out. Okay, because I moved this content from Evernote to this markdown is not completely filled. Once it is there, you will be able to see the code alignments properly. So what I'm trying to say is this is what this observability is all. Observability means it's something related to the log data. It is something related to the metrics of the system. It is something related to the system traces. It's something related to the performance. So every variety of data is what we call as telemetry data. Okay. So in your infrastructure, whether it is in containers or virtual machines or running in cloud or on-premise, whatever it is, you know that you have to you get huge amount of data. Okay, huge amount of data. That is, all the data can be categorized under one word called telemetry. That's what we call as system telemetry or telemetry data, or sometimes they have say open telemetry standards are there. I don't know what was that. I'm still researching that. Okay, so that you collect lots of data from your given infrastructure. Okay, so your infrastructure, container, VM, or anything that it is, it generates these much amount of data and many more other data also, real-time data. And that data, what you are going to do with that data? That's what we call as the telemetry data. That's what we're going to deal now. So telemetry data is something which you see here. Um, what I've been showing here, this one. This is also a telemetry data, considered like that. Suppose if you want me to show the output of it stop, here you see this CPU processing output, CPU utilization and all that. This is also telemetry data. This is also telemetry data. Okay. So whatever I'm just trying to hook up from the system, it's all a part of telemetry data. It's all considered like that. Suppose if you want to get how much a process is being consuming, that's also a telemetry data, performance level telemetry data. So whatever metrics you get, the numbers out of the system, okay, be it containers, VMs, anything on premise or cloud, it's all generally categorized under telemetry data. Okay, we are now going to use a script. Okay, that script is going to write or calculate a telemetry data, and for now we are going to calculate only, but we can push that to integrate that script with ELK or Nagios. You may have heard about systems like the Nagios. There are very famous, I think there is a comparison here. There are very famous observability platforms, Splunk, Nagios, New Relic, Grafana. So there are many things. So these are all the very trending tools, okay, in the modern day DevOps world, that you can use all these tools to collect the telemetry data and process it, and you can build beautiful graphs. Okay, that's where we actually learn Elasticsearch, LogStash, Kibana to do all that. Okay, so this is the application of telemetry data in the practical DevOps world. Okay, so we're able to understand, right, why we are actually doing this this exercise of scripting. So why I'm saying all these things is this is all going to now come under this script. You now know what is telemetry data. You now know how telemetry data can be used in an observability platform, at least an idea. And now we are going to write the script, okay, which is going to take the telemetry data from the system and simplifies and processes that output and makes the life simple for us. for an observability plot. That's what we're going to do. Now, after giving all this background, okay, we should be able to really understand what I'm talking about. So I'm going to now why I went there, why I went to all that place. I just want to show what is telemetry. Telemetry is nothing but your system load is a telemetry information. Your system storage level informations, metrics are a telemetry information. Your system CPU utilization is a telemetric information. If your system is all these, okay, memory RAM, okay, we've learned this command called free-m. One day I told a formula and we all calculated this memory. What is this? This is all in DevOps observability context. This is the telemetry information. Very simple. That's all. Okay. Maybe I don't know. We may say it's a metric or a RAM fill. It's a standardized word. Telemetry data. That's all. In DevOps observability context, I'm saying. Okay. So we are going to process these kinds of data, specifically the RAM, memory, and the storage. That is your storage in the system, hard disk drive or SSD storage, and system load. So these are the things we are going to calculate. Okay. So what is the system load? Generally, I know we have learned. So because of that, we go here and we try to hit W command, and then we get that output. Okay. So if I ask you what is 1 minute load, you can say this 2.32. What is 5 minutes? 1.83. What is 15 minutes? You can say that, okay, very easily. But how about an observability platform knowing that this information? So we need to somehow simplify this information. You can't just run the W command output and put that output directly to it, because it does not know how to process it. We need to now simplify and get, suppose I want a script. That script can, I can say, I want 1 minute load average. So it just prints this number alone. I don't want all these outputs. If I want to know what's the memory, I don't want all these outputs. I want to know the used memory. I just want this number alone. I don't want this all numbers. So when you want to pump data to, building a pipeline, data pipeline or something, you have data in different formats. This is an unstructured data. Now, I'm not talking any data engineering concepts. Very clearly, I'm cautiously saying that. I'm not talking data engineering concepts here. Okay. But I'm just saying in a common sense, this is fairly an unstructured data. You can't do much with an unstructured data. This is totally out of structure. You can't tell a observability stack to send this type of data, and it cannot process things on its own. We need to have some kind of intelligence on that. Okay. So our script is going to do that intelligence part by taking this unstructured, so many different data, processing that and picking the right information we want and to send it to observability platform. You get the point, right? Your system, your Linux machine or a Unix machine, you have so many commands and things, low level things. It throws so much amount of output. You can't sit and do all that. As a human being, if I ask what's the 1 minute load, I can select this one. But how can the observability stack know how to select this one? That's not possible. Okay, we need to somehow find a way to properly select certain things and send certain things properly. That we have to do. Okay, that's why we are writing a script. Okay, so the purpose has to be very, very clear. I'm not talking about writing an hello world script. Okay, writing an hello world or something, you don't need to learn all these things. Anyone can go to Google and write it. When you solve a real DevOps use case, we have to go through the right iteration process. Okay, so now coming here, as I told, we are going to now write the logic. How does the logic is going to look? So the logic is going to look like this. Okay, you see here, now I'm just copying this one. Right. Okay. So what are we going to do is define functions. Okay, this is the 6th step. And this is going to be a bit bigger step. Okay, bit bigger step. You see here, define functions means I'm going to break down my functionalities. Like Alex said that I'm going to break now my functionalities. Okay, in what aspect or in what basis I can break my functionalities. Okay, I know I said that defining functions, but how do you, in what basis you are going to break down your functionality? We're going to break down our functionality in the basis of simple, in the basis of um, different telemetry data, calculating system load, calculating the memory, calculating the storage. What is the 1 minute system load? These are all the bases in which we are going to break down our functionality. Okay, so I'm going to now write it like, let's say, I'm going to say write a function. Maybe I can choose a bit red color because that would be a bit appealing here. Function, and then you have, let's say, calculate underscore load, or calculate underscore system. So function calculate system load is the what is the name of the function. So that's our functionality. Okay, you see now the function. So function calculate system load is a function. It's what we call as the function definition, and it has some kind of a functionality. Okay, basically, what does that actually contain inside when I say functionality? Calculating system load is a functionality. Okay, it is going to have something like, yeah, we have some code. So this is what we call as the logic. So where we write our logic. Okay, so I just try to put a small arrow mark. So this is the sorry. So this is the, maybe I think this is inside. I think I have screwed up that one. How do I write it means? Wait, guys, I couldn't able to get that arrow outside. Wrong. Okay, here. So what is this dotted lines? This is all what we generally call as this the business. Business means honest, right? Business logic. Okay, this is what we call as the business logic. Okay, business logic. And similarly, if you see here, I want to have different functionalities in my script. It's not just system load alone. I want to also calculate system memory. So what are the different types of memory you have? You have the free memory, used memory, available memory. And then I also want to calculate things like, I want to calculate what are the other things I told here. System load, memory, and storage. Okay, so calculate storage. Okay, so basically we are going to build three types of three functions, okay, altogether. And these three functions are nothing but the functionalities in the script. And this is what we call as the function definition. Okay, if you want me to write, every function, what does that do? Okay, because when we write the script, we actually do it in this way. But I now show how to actually write that. Every single function that you write, on top of that, you need to have a comment about that. Okay, on what that function is going to do for you. Okay, so I'm going to now write it like. So this function allows you to calculate what 1 minute, 5 minute, and 15-minute load average. Okay, so this function, you don't need to write the allows and all. Calculate 1 minute, 5 minute, and 15-minute system load average. So this is what this function is going to do. Okay. Similarly, I'm going to write another function, and that function is also going to have a piece of the logic. So, sometime back I told whatever you write with the hash, it is called as description. Okay. You can write in the top, that's for the script, but every single function, as a good programmer, we have to write it in this way. Okay. So this function, the memory function, is going to calculate the free, used, and available system memory. Okay, So we're going to use this function to do it. And there's another function. Okay, so what this function is trying to do. So I'm just trying to literally write it in a way that, this is the way how we are going to write the code. If you can break down things in this fashion, I think writing the code is not a big thing. It's all about just copy pasting the syntaxes. Okay, understanding the structural values is very important. So you see here, so calculating the free, used, and available system storage. Okay, so that's all. So this is how you design a script. So whatever complex use case. So in your company, if you face so much big complex challenges, or whatever, even if something is a short script or whatever it is, the strategical way is same. You see, that this is not going to change. Suppose if you have a very big thing, you just try to write it in function. Maybe you may result in some 20-25 functions at the end of the day. That's okay. It's not a wrong thing. Okay. So now what is functions? Why do we write, as I started this thing? So why did I actually came to this function? So, most of the time people write script, they put all the commands and things tightly, plainly. It's called sequential coding, and that's not the best way to do it. The code has to be reusable. The code has to be extensible. The code has to be modularized. The code has to be importable. All these things, how do you get? Functions. Functions is writing everything as the functions is the only one way you make your code modularized, portabilized, and then you have callable, and then you make it extensible and importable. So all these features comes only if you write code and functions. Okay, that is what is first we need to write. First we need to understand. Now, if you see here, now I'm giving the explanation for this. Okay, so explanation in the sense, so how do I now interpret what this function? So functions allows you to make your code, make your source code more callable, reusable, okay, and modularize, and portable. Callable, reusable, portable. 3 words you need to remember. Functions allows you to, this is the advantage of writing things in functions. Okay, I'm not talking about object-oriented programming like the oops and these kinds of stuffs and all that. And we're just talking about plain function writings. Okay, when you write it like that, your code becomes callable, reusable, and portable. That's all. These 3 things is very important. Okay, then that's the reason why from the first run itself, we must start writing code or look code in that aspect. Okay, so that's very, very important for us. Okay, as sometimes people say DevOps engineers means we just need to write some small code, and okay, yeah, even whether you have to write a small code automation or a very huge code automation, given whatever it is, the important point is we have to write it in this way. This is the best way of writing program. Okay, and this is the most reusable. And whoever wants to extend this code, he can just add another function and extend it. That's all. Extensible, reusable, portable. Okay, I can load this script file in another thing, and I can call this function from another script. It's easy. All these things are possible only if you write it in this way. Otherwise, it is not at all possible. Okay, that's the first thing. Now, this is what we generally call as the definition of function. Okay, so if I want to put it in technical aspect, I just try to write it like here. Define, what did I give here? One second. I'm sorry, I think we can write it here itself. So here you can modify. Define functions that allows you to make source code work. Okay, callable. That's all. Okay, and then now we have come to the 6th step, building block in this view. Okay, we have now come to the 6th step. What is the other step? You define the functions. So the functions, will the functions be just like that executing? No. It doesn't work that way. Defining functions means it's defining, it doesn't execute it. Okay, we'll see that in the workout. Now, what's the next way of doing it? The next way is, we need to make or call the functions. Okay, this is where the things are different. Most of the time when we learn these kinds of topics in the colleges and all that, I know 99% of the time we learn things and do things, and even in industry, corporate industry, where people do these things, haven't really got what it is all about. Okay, so what I told is defining the functions. Now we are going to call the functions. Okay, so basically when you are a good scripter, when you are a good programmer, your approach should not be like just you put something and run it. It isn't that purpose. We need to make a better CLI interfacing for our script. Our script is not just like that. You put the script, hit it, and run it, and you can't put any arguments. And sometimes that kachamucha arguments we go and take. That's not the way how we have to write it. Okay, we need to handle the arguments in a streamlined way. Okay, and pass it to the functions and make the functions callable. So handling. Okay, handle CLI. Okay, or else maybe command line interface plus call functions. Okay, CLI handler. I think once again, CLI handler plus call functions. So this is the logic. Finally, you will have. I believe this is 7th step, 6th, and this is the 7th. 1, 2, 3, 4, 5, 6. Totally 7 steps. So the 7 steps. So the CLI handler and calling of the functions is the place where you are going to click what function you want and execute what function. Okay, so this is the place where that happens. Okay, writing the business logic and putting the functions in place is one thing. That's a huge part in your script, and this is not a huge part. It's a small part, last part in your script. Okay, so what this is going to ultimately tell you, how to get some user input. Basically, CLI means it's for the users. Okay, so get input from human, from system users, and or let's say users. Don't need to be more technical. Get inputs from users and process with CLI handler and execute the appropriate spelling right or wrong, appropriate function. Okay, so that controlling. Okay, maybe I think instead of handler, I think I can say control. So spelling controller, CLI controller. Okay, or something like that. CLI controller, and then you just do it. Get input from users and process with CLI controller and execute the appropriate function. Whenever a certain, it's the same script. Same script, you can write it with different angles. Okay, so sorry, you can execute it with different arguments. It will put different outputs, but only one script file you write. One script. Not many scripts. That's how script becomes effective if we write to put all things as a functions and you project it like that. I think it looks very sweet and very good to actually, one script, very portable, and process different arguments and gives the expected outputs. Now, if you see here, this is this is a common thing. Okay, if you ask me, the final point here in this diagram is, this is a very common thing for Ruby, for Python, for shell scripting. So I'm going to name the script file. Now, this is a script view, but I'm going to now name the script file. So what's the name I am going to give for this script file is, I'm going to give the name of the script file as system metric, because we also already have the script in the GitHub. Okay, and we have that's a very clearly written script, but we can't write that way in the session time because I myself lose lots of syntaxes. We can't hold that in the memory. Okay, so we may do mistakes, and script won't come 100%. It will come 90% or 95%. That's what will come. Output will work. Okay, so I'm going to say this script is like this is a script name. Okay, the script name is metric.sh. If it is shell script, if it is going to be a Python script, I'm going to name it like system metric.py, and then system metric.rb. So given whatever it is, if it is a we can use it this black itself. Okay, system metric.sh, system metric.py, system metric.rb. RB means Ruby. Okay, I will write that as well. Ruby. Sorry, shell. This is bash shell. Okay, for bash shell, this is like that, and this is Python, like that. Okay, like that, and then you have the system metric Ruby. This is RUBY. This is name of the script file itself. We are going to make it more consistent. Okay, only the final extension RB PySsh is going to actually be the difference. Okay, but it's not even bash shell. If it is shell script, you write it as this. That's all. File name. This is the name of the script file that can be executed. That's all. Script file name. That's it. Okay, and the primary purpose, okay, as I told in the top, this script it's going to calculate the system telemetry. So we need to also write it in a bit better way. So when we tomorrow reference the script, you know that the script is all about doing this system telemetry processing. So I just try to, I don't know how to use the double-headed arrow, but I just use this single-headed arrow to show that. Okay, so what's the purpose of the script? The script's main purpose is to calculate system telemetry. That's the purpose of the script. Okay, so we need to make it slightly large text. So calculate system telemetry data from a Linux machine. Okay, this is the way how we actually look into this kind of scripting structure. Okay, so I just minimalize this one. Now you get the point. Now we are actually done 50% in our work. 50% is over. Okay, if you do a planning like this, okay, I think your 50% of the job itself is over. You don't need to really do anything fancy to, you know, I don't believe there is anything difficult in that. If you approach it in this way, I think there is nothing to do. Okay, only syntactical things you have to know. Only a bit of logics we need to know. For that, we need to have Linux commands and Python syntax or Ruby syntax like that, and then the output will be very simple. Okay, so this is the way how we have to look into this. Okay.